This content is AI generated for informational purposes only and should not be directly used for clinical decision-making.
Hello and welcome back to the Neurosurgery Hub podcast. I'm Dr. Aris, a senior attending here, and I'm joined as always by our research fellow.
And I'm Dr. Alara. Today we're looking at a fascinating new study from World Neurosurgery 2026 titled The Patapata Articulating Dissector for Endoscopic Neurosurgery, Improving Precision and Expanding Surgical Access.
This is a topic close to my heart, Alara. We've all been there, performing an endoscopic procedure deep in a narrow corridor, and you just can't quite reach a lateral corner because you're limited by the straight line geometry of our current tools.
Exactly, Dr. Aris. The paper starts by addressing that exact frustration. While endoscopic neurosurgery has revolutionized minimally invasive access to deep-seated lesions, the authors point out that surgical manipulation is still heavily restricted by the limited maneuverability of straight instruments within those narrow corridors.
Right. If you want to reach something off-axis, you often have to tilt the entire shaft, which puts unnecessary pressure on the surrounding brain tissue or the nasal mucosa in endonasal cases. So what's the solution proposed here?
The team developed what they call the Patapata Articulating Dissector. It's a clinically applicable tool designed specifically to enable multidirectional distal-tip motion without requiring any movement of the shaft itself.
That's the holy grail for endoscopic work, keeping the shaft stationary while the business end does the work. Let's dive into the technical specs of the device. How did they manage to fit an articulating joint into a neurosurgical instrument?
It's impressive engineering. The Patapata uses a miniature pulley tendon system. Despite the complexity, they've kept the diameter down to just 3.2 millimeters. This means it fits perfectly through standard 4 millimeter endoscope working channels.
3.2 millimeters is quite slim. And what kind of range of motion are we talking about at the tip?
The distal tip can bend up to 90 degrees in 4 directions. This allows the surgeon to reach around the corner, so to speak, in a way that's simply impossible with a rigid straight dissector.
Now, a tool like this sounds great on paper, but how did they validate it?
They conducted a rigorous preclinical evaluation using a synthetic brain model. They compared the Patapata Articulating Dissector against standard straight dissectors across 2 primary categories, point-to-point targeting and tissue dissection.
And I assume they were looking at more than just whether it could reach the target.
Much more. They measured surgical reach, precision, and efficiency. The results were quite striking. The articulating dissector showed significant improvements in all 3 areas, but perhaps most importantly for us as surgeons, they measured shaft tissue contact.
That's a critical safety metric. In neurosurgery, every millimeter of unnecessary brain retraction or shaft tissue friction matters.
Precisely. The study found that the Patapata significantly reduced shaft tissue contact because the articulation at the tip handled the maneuverability, meaning the shaft stayed centered and still in the surgical corridor.
That's a game changer for deep-seated lesions. If you're working in the third ventricle or the skull base, being able to dissect a tumor off a cranial nerve or a vessel without prying the whole instrument against the corridor walls is a huge safety advantage.
The authors emphasize that this device effectively overcomes the straight line constraints that have traditionally limited endoscopic neurosurgery. By expanding the surgical envelope, they suggest we might be able to expand the indications for endonasal and intraventricular procedures that were previously deemed too technically difficult due to restricted access.
It really feels like we are moving towards a new era of dexterous endoscopy. Instead of just seeing around the corner with angled lenses, we can now finally work around the corner.
It's a significant leap. The paper concludes that by improving precision and expanding access, the Patapata Articulating Dissector could become a staple in the neurosurgical armamentarium, especially for those complex cases where the anatomy isn't in a straight line.
Well, I'm certainly looking forward to seeing this move from the synthetic model into the OR. It's a great example of how engineering can solve the physical limitations we face every day in the bunker. Thanks for breaking that down for us, Alara.
My pleasure, Dr. Aris.
And thank you to our listeners. Join us next time on the Neurosurgery Hub podcast as we continue to explore the cutting edge of our field. Stay sharp.